All right, let's get to it. So yeah, the assignment that's going to show up on Delta Math, if you get a little notification, just ignore it. Close your Chromebook, please, back there, Levi. Thank you. Just ignore that. You'll have time to work on it today, probably a lot of time. And then tomorrow, I'll add in assignment number 11, which will not be on Delta Math. It'll be a PDF, like a paper assignment. Those will both be due Wednesday. And then Wednesday, I'll have some form of probably like a practice quiz for you. And then the quiz will be Thursday. Okay. So if you have any questions over the next day or two or three, make sure you ask them. All right. That's what I'm here for. So today is 9/12. And I hesitate to even call these 4-step equations. I think from this point on, we're just going to call them multi-step equations. And I've got 9 examples for today's notes. Each one should take a minute or two, so this shouldn't take all too long. But there's a kind of a new main idea here today. So let me put the first example on the board, and then we will talk about kind of like the big picture. I mean, our main objective doesn't change. Our main goal is still to eventually put the variables on one side and put the numbers on the other side. We've talked about that ad nauseum. And then to divide or multiply, whatever we have to do to seal the deal. But today, what happens is there are now steps that occur before that. So a typical 3-step equation, our thought was, let's get the x's to one side, get the numbers to the other side. There's 2 steps, and then divide. Boom, there's 3 steps. There's work now that has to happen before that. And this is, again, I get one shot to not mess this up. So I hope you hear this through your yawns and boredom here. You're good, bud. I feel that. You have to simplify before you solve. And you'll hear me say this a lot over the next couple of days. The main idea here is to look at the left side of the equation as if it were its own little math problem, and then look at the right side as if it were its own little math problem, and do as much math just on each side as you can. This goes back to assignment 6, which I know was like a week and a half ago, but in assignment 6, we practiced distribution, combining like terms. So we're basically going to treat each side of the equal sign like its own little baby issue. So like I do the left side as much as I can, I do the right side as much as I can, and then I will see either a 2 or a 3-step equation once all that has been completed. So in this case, you look at the left side of the equal sign, what do you see? Right, more specific. I agree. There's math to do. I mean, I think you were trying to be sarcastic, but really there is math to do. So what math specifically do we do? The multiplying, the parentheses, that D word, the distribution, right? And so I'm looking at the left side of the equal sign and saying, well, I need to clear out those parentheses. And so I'm going to take the 3 and I'm going to distribute it through these parentheses. What is 3 times y? Nice. And what is this 3 times this minus 5 going to give me? Minus 15. Very good. And having completed this now, I look at the left side, and this is the part that I'll harp on you about. And some of you will pick this up right away. Some of you, it'll take some nagging. When you look at just this as a math problem, if this right side didn't even exist, would you look at that and say that that itself is simplified? I agree. You can't put 3y and minus 15 together. Those are not like terms. So it's at this point where we look at the problem and say, okay, I need to now solve this equation. Simplifying comes before solving. And so at this point, this is a standard now 2-step equation. What would I do to both sides? I would add 15. Very good. Cross out your inverses and then rebuild the equation. The biggest mistake people make is they get all, I said this last time we learned this, is to get all crazy and worry about the math. You worry about the math once the structure is ready to take it. Now I care. What is negative 21 plus 15? Definitely negative 6. So this is going to turn out to have been a three-step equation because now we have to divide by 3 and divide by 3. And we're going to be left with the solution, which is y equals -2. So when you think about steps, step 1 went from here. The green arrow is step 1. Step 2 is the yellow arrow. That's us adding 15 to both sides. And then in this case, step 3 was dividing by 3 to give us the final answer. This doesn't have, that's why I said I was hesitant. I didn't want to call today specifically 4-step equations. Some of today's problems will have 3, some will have 4, some will have 5. I don't think we'll go above 5. I don't think there'll ever be an instance until we get to fractions where there will be any 6 or 7-step equations. So 5, I think, will be our limit for today. Everybody got this so far? Okay. Next one. This will feel largely the same as the first one. I just kind of want to reiterate this point, drive it home. So we have 24 equals -8 times the quantity of 2x plus 7. This ought to feel pretty similar to the first example. It's got a little bit of trickeration to it. Number one, I obviously moved the variable to the other side. No big deal. We don't care. And what really catches our eye here? What makes us kind of perk up and say, like, danger, danger? I'm not worried about the 2x. It's that darn -8 in front of the parentheses. And so when we do that D word distribution this time, we've got to be on our A game and remember that distributing a negative changes the signs of everything that it comes into contact with. So we're going to copy down the right-hand side, or the left-hand side, excuse me. So 24 equals, there's nothing to do there. But on the right-hand side, here we go. Don't be goofy. What's -8 times 2x? Always has been, -16x. And what happens when I take this -8 and I distribute it across to a +7? It turns into minus. Negative, or you can say it kind of either way, but you can't say both. You can't say minus a negative, of course, that would mean something else. So I like to just read it like Zane did as just minus 56. Nice and clean. Everybody okay so far? Brenny, you good? Okay. And at this point, once again, we kind of see now what's coming down the pike. We see that this is going to wind up having been a 3-step equation when we're done. Step 1 was to clean up the right side. But now that there's no more work to do on that side, it's time to actually solve. None of the things that we do are called solving until we start getting to the point where we're moving things across equal signs. Now we're getting into the solving. All the stuff before it is just housekeeping, tidying up. So what do we have to do at this point? Yeah, anything else would not make an ounce of sense. Adding 56 is the only way to go because we're mindful of keeping some stuff on the right and on the left. We don't want to void out one side. So the 56s are going to cancel. Before we worry about math, we're going to drop the -16x. We're going to drop the equal sign. And what is 24 plus 56? Definitely 80. And then from here, the last step is to divide by -16. Cancel out your inverses, rebuild the equation, then do the math. What is a positive 80 divided by a -16? It is. Okay, any questions so far? Okay. Bryce, you okay, bud? Did you hit your humerus? Right. Sorry. Example number 3. We're going to take 5 times the quantity of -x minus 4. And then we're going to add 2x. And then we're going to take away 3. We're going to set that equal to -2. You'll feel this one as I think a 4-step equation. And you'll see in a minute when they jump to 5, I have 2 more examples like this one and one more. And then the variable is going to start appearing now on both sides. And that's when we'll see our first 5-stepper. So for this, the first step, I hope it's obvious to you, is to distribute. Right. That's just going to be a non-negotiable for us. Those parentheses have got to get booted out. So my distributor is a 5. So I'm going to take 5 times the first guy. What's that? Good job. Negative 5x. And then I'm going to take 5 times an already negative 4. What do I get? Mm-hmm. And again, you can say negative 20 or you can say minus 20. Just don't say them both. Pick one. And then I'm going to copy down some more stuff. And I don't want to put too much of the blame on myself, but I feel like for many, many years, I have failed at this critical juncture right here. I know that I'm failing as your teacher if you don't hear what I'm about to say. Do not do anything at this point that involves the words both sides. Don't add 3 to both sides. Don't subtract 2x from both sides. Don't add 5x to both sides. Don't add 20 to both sides. That is completely and totally an inappropriate thing to do. Because if I look only at this left side, I'm going to ask you, I think, what is a rhetorical question. Is the left side fully simplified? No. Then you do not proceed with solving. You're still in simplifying. You're still in the tidying up stage. I'm still thinking to myself, this isn't a show work stage. This is just me combining some like terms only on the left side. So no, I don't want to see plus 5x. I don't want to see minus 2x. This is just back to assignment number 6, where we learned, or for some of us reviewed, how to combine like terms. So I hope you would agree that negative 5x is a like term with plus 2x. And what happens when you add negative 5x's with plus 2x's? You just get negative 3x. And I hope you also then would agree that minus 20 and minus 3 are like terms as well. What happens when you add them together? You get negative 23. That will be the step right there where I don't know how many people will go rogue, but that will be the one that causes the most demise. Don't solve the equation at that point. Just combine terms. The left side and the right side need to be completely clean, and now we can proceed. We've done 2 steps so far, and neither one of them is really solving. But now it's time to solve, because when you look at the left side, those 2 terms are not alike, so it's time to solve. What do? We have to add 23 to both sides to complete the separation, to complete the idea that, okay, variables, nice and clean, you own the left side. Non-variables, we call those constants, you own the right side. We're right where we want to be. And what's the last step? We're going to divide both sides by negative 3, giving us our solution, which is x equals negative 7. So there's an example of a 4-stepper. Step 1 was distribution. Step 2 was combining like terms. Step 3 was booting the 23. Step 4, finishing the job. Okay. Still good? Okay. One more of what I perceive to be sort of a warm-up, I guess. I don't know. Let's do this last one. Again, there's a whole bunch of math that we have to do before we can say, okay, I'm going in now to solve. I have to clean house. Looking at the left side, what has to go first? Parentheses, distribution, multiplication. There's so many different ways to say it. Bottom line is these parentheses should just be calling out to you. Please clear me out, clear me out. So when I multiply -2 by -x, what do I get? I get positive 2x. And when I multiply -2 by a positive 1, what do I get? You get -2. It can be a -2 or it can be a -2. Some people say it differently as long as you understand net result that there's a -2 there. Think of it as a negative if you want. And then we're going to copy down the rest of the problem. Now we're going to combine like terms. We're not going to subtract something from both sides. We're not going to add anything to both sides. We're going to acknowledge that the left side is a mess. So when we put our like terms together, we should identify that there's a pair of them right here. What do they make? Yes, they do. And we should also identify that there's a pair of them right here. What is -2 plus 3? Positive 1. Still good? And at this point now, having done two things, we're ready now to go in and say, all right, I'm going to go ahead and solve this now. I have no choice now but to say the words both sides, because that 1 and the 14 are destined to join forces. So what do we have to do? Subtract 1 on both sides, and we're going to be left with 5x equals 13. And remember, this does not mean that you're always welcome to walk up to my desk and ask for help, but this doesn't mean you've done something wrong. But your radar kind of does ping, and you say, oh, 13 can't divide by 5. That doesn't mean you're wrong. Fractions are a perfectly common and acceptable occurrence. So what do we do to both sides? We divide by 5, and we just accept the inevitability of this. We say, well, I guess it wasn't meant to be a whole number today. And as my teacher said, just leave it as a fraction. No one's interested in 2.6. There will come a time when we like that, but for now, just leave it as a fraction, man. Even mixed numbers, no need. Don't do extra work. Once you know it's going to be a fraction, just leave it alone. Okay, 4 examples down. Do we feel good so far? Okay. So the rest of these now will share a new theme characteristic, and that is that the variable is now going to start popping up on both sides. So for this one, we have 5 minus the quantity of 2x plus 2 is equal to 4 times the quantity of x minus 6. What do we have to do first? Distribute, right? And you can do it on both sides. It's fun because, not fun, but it's nice because you can work on both sides, because the results of what you get on the left and the results of what you get on the right, they're not affecting each other yet in any way. So what am I distributing over here on the left side? It is not the 5. The 5 has nothing to do with this. It's the minus sign. And for some people, it really helps them to put a 1 right here. I do it just because I'm your teacher, but like if I was just sitting here working alone, I wouldn't do it. But it helps me to remember, helps students to remember that, oh, the 5 can just wait. So I take the 5 and I just copy it down. It doesn't get to play in the first step. Now, when we distribute the minus, what do we get for that first one there? We do. We get minus 2x. And when we distribute the minus to the 2, what do we get? Perfect. And then on the right side, what's distributing through the parentheses over there? The 4. And what is 4 times x? Nice. And then the 4 has to distribute to the -6. And what do we get, Bryce? Definitely. And again, we find ourselves at a very important crossroads. Do I want to take my teacher's advice, or do I want to just think he's a quack and do my own thing? Am I ready to solve this equation? I am not. Wholeheartedly, caps lock, 48-point font, bold, underline, no. Because why? Because it's not simplified. I look at the right side and say 4x minus 24. I'm content with 4x minus 24. But the left side, I just look for them. I train myself today and tomorrow and Wednesday and Thursday. I train myself to say, I'm not proceeding until this and this have just been put together. And what is 5 minus 2? It is positive 3. So now I'm going to take that 3 that I just created. I'm going to copy down the minus 2x. I'm going to copy down the equals and the 4x and the minus 24. And you can see now that we have done 1 step, 2 steps, and we have now in front of us what I think you recognize as a 3-step equation. So this is where our training kicks in now. This is the crossroads that most equations, quite frankly, will arrive at. You'll do a couple steps and you'll get here and say, what do I do now? So you know how I feel about this?
The variables on one side and the numbers on the other.
Yeah, and which one should we deal with first? Always the variables first, and always more specifically the smaller of the two. As far as I'm concerned, this 3 and this minus 24, they're not even here. I'm not even looking at those guys. I want to control my x's while I have a chance. So I'm going to focus on them. And clearly negative 2x is smaller than 4x. So he's the one that I'll remove. I'm going to add 2x to both sides. I'm going to cross off my inverses, and I'm going to rebuild an equation. I'm going to have 3 now equals 6x minus 24. And then, of course, it's a 2-step equation now. Cruising along, we're going to add 24. Cross off your inverses, drop your 6x, and then do a little math. 3 plus 24 is 27. And again, your little spidey sense pings, and you say, I'm not going to be able to divide this out. And so we're going to divide both sides by 6. We're going to be left with, yes, a fraction. It's okay. So what would be wrong if I left my answer like this? It's not simplified. It's not reduced. And so, I tell you, don't make your fractions into decimals, and I stand by that. And I tell you, don't make your fractions into mixed numbers. I stand by that. But I, along with anyone else who does this, will tell you, you still have to reduce. Reducing just means I'm going to make the fraction as simple as I can. Not change it into something else, just simple. What can 27 and 6 both be divided by? 9. They can both be divided by 3. It's okay, Zane. Keep firing away back there. And when you divide the top and the bottom both by 3, you get 9 over 2. And that is an answer. I consider that a 5-step equation. I don't really view simplifying the fraction as a 6th step, but you could make a case for that. That one feel okay? All right. Next one. I said this a while back, the equations, while they may look like they get harder, they just don't, as long as you embrace the fundamentals. Fundamental number 1 is simplify each side. That's it. Distribute, combine like terms, do all that stuff before you ever utter the word solve. So on the left side, what are we going to do? Good. I was hoping you'd start saying that word. Distribute, distribute, distribute. Good job. So what is 6 times 4x? And what is 6 times an already minus 3? Negative 18, minus 18, either way. And then you copy down a bunch of stuff. And if you want the whole thing to fall apart, this is where you would say the words both sides. You don't want that to happen. So you focus on the left side as if it were the only problem given to you. What do you see? What is 24x minus 10x? So I'm going to copy down now 14x minus 18. And on the right side, my like terms are not variable terms. They're what we call constant terms. And what is, let's put little arrows to them. What is negative 8 plus 17? Positive 9. So we have 5x plus 9. People sometimes ask, like, is he ready for algebra? Is she ready for algebra? And my answer is always, anyone's ready for algebra if you can add and subtract and know your times tables. If you know that negative 8 plus 17 is not negative 25, you're ready for algebra. Everything we do revolves around your ability to just add and subtract. That's it, dudes. Because here we are now. We've done 2 steps. We've got 3 to go. So it's time to focus on the x's because the left side is clean. The right side is clean. Who are we going to destroy? Definitely the 5x. Again, I don't love the left side. I don't love the right side. I love having a variable term that does not have a negative in front of it. It's my choice. So what is 14x's minus 5x's? And then we copy some stuff down. What is the next step? Add 18 on both sides. Very good. And we're left with 9x equals 27. Last step. Next step is not x equals 3. Next step is to divide both sides by 9. And the result is that x equals 3. If I haven't convinced you yet that these are not hard, I'm not doing my job. You just have to know the steps. Distribute, combine like terms, clean, 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 and then move the x's, move the numbers, divide it out. Bryce, turn around, please. Zane, don't. I mean, if I had given this to you a week ago, you probably would have thought like, oh my, I don't know what this looks hard. No, we got this. On the left side, there's distribution, and on the right side, what is the distributor on the left-hand side? It is, yes, just the minus. Remember, the negative 9x has nothing to do. So we're just going to say, why don't you just go ahead and copy down so I don't do anything stupid here. I'm certainly not going to distribute you. You're not the one attached to the parentheses. That minus sign is. What happens when this minus sign multiplies to this? It becomes positive, so plus 3x. And what happens when the minus sign distributes to this? Plus 2. And then on the right-hand side, my distributor is another minus sign, or a negative sign, if you will. And what is this multiplication here? Negative x. And then this negative multiplying by this 3 makes negative 3. Are we ready to solve? Not even close. On the left side, I see like terms. They're x terms in this case. What's negative 9x's plus 3x's? Definitely. And as advertised, we see now a very typical sort of textbooky looking 3-step equation. 3 to go. Move the x's, move the numbers, divide it out. Which x should we move? Negative 6 is smaller than negative 1, so we want to destroy the negative 6x. Cancel out your inverses, rebuild the equation. It will say 2 equals 5x minus 3. Now the path is set. What do we have to do? We're going to add 3 to both sides. Drop down some stuff here, right? We got a 5x dropping down. We got an equals dropping down. 2 plus 3 is 5. Last step. There you go. Divide by 5. X equals 1. I did skip one of my examples, and I know earlier, if you were paying attention, I said there would be 9. We've done 7. We're only going to do one more. I took one out because I felt like it was redundant. So we've got one more example, and then the rest of the time today and tomorrow, you're going to be just doing a lot of work. There won't be any more lectures for a couple of days. So here's your last one. -2 times the quantity of 8x plus 1 minus 1 equals -7 times the quantity of 2x minus 3 and then minus x. Would you guys like to try to solve this without my help? Go for it. I don't know how long you need, but I'll kind of gauge it by when I start getting answers. So same drill as last week. If you get an answer, please let me know. If someone else says your answer, nice. If you have a new answer, I want to hear it. Bless you. Okay. Say it again. -6. So the answers are starting to populate in red up there in the corner of the TV. If you get something other than those, let me hear it.
I got -22.
Okay. You get one of these, Seabass. Brenna, you still rocking, or did you get one of these? Okay. I feel like this one becomes a 4-step equation. And if you know why, I believe, if I'm seeing this correctly, that at the end, when you put your x's together, I think you just get 1x or just x, which means that dividing is something we won't have to do. So I believe we're going to have a distribute step, a combined term step, a get the x's together step, and get the numbers together step. And that will be the end. So 4 steps is what it should have taken you. Don't ever divide by 1. Okay, that's a bad habit that sometimes people who get 1x like to put that, and then they go, oh, I better divide by 1. I hope you realize how silly that is. It's just like totally pointless. I'm going to get rocking here so we can get some work time today. So I'm going to walk through this. I'm just going to do my thing. On the left side, I'm going to distribute -2, and I'm going to get -16x. And then I'm going to change my sign and get -2. And then I'm going to copy down the -1. And then on the right side, I'm going to distribute -7 and get -14x. And then on my -7 distributor is going to hit my already -3, becoming a +20. That is exactly what your first step ought to look like. Did you forget to put the plus on the 21?
I forgot the last X.
Smooth.
Oh, yeah, you know.
I am now in the combining like terms step. And so on the left side, my like terms are the ones that don't have X's. So I'm going to just put them together to make a -3. And then on the right side, my like terms are the ones that do have X's. And there's -14 and -1 more for a net total of -15. And this is what I was talking about, is that if I am a listener, if I take guidance and instruction, I realize that -16x's is smaller than -15x's, so I elect to add that one.
Wait, I didn't forget the X. I'm just not.
I'm going to cross off my inverses, and I'm going to be left with -3 equals. And it's critical here that I think you not write 1x, because I put this together with this. No, -14 minus 1 means you borrowed $14, and then you borrowed one more dollar, which means overall now you owe not $13, but $15. Remember, minus means to go left on the number line. Numbers get smaller. And in the world of negatives, it looks like they're getting bigger, but that means they're getting smaller. So on the right-hand side, -15x's plus 16x's is +1x. I elect not to write the 1, because then I'll think I got more work to do. Like, hey, jackpot. And then I'm going to subtract 21 from both sides. So whoever came up with -24 is correct. Okay. So on your Delta Math, there is a new assignment. His name is, that took a little longer, but that's okay. There's lots of work time in the coming days, so don't sweat it. There's a new assignment. I believe it's number 10. Yep. And I have it marked as due Wednesday. So we're going to work really, really hard for like 12.5 minutes. And then we'll take 23 hours off, because we want to watch the Broncos and Seahawks tonight. You don't want to be doing math homework during the Broncos and Seahawks. Am I right?
Right.